What if an AI could look at a chest x-ray and spot pneumonia, maybe even faster and more reliably than a person? Well, that's exactly what we're diving into today, how a deep learning model gets trained to diagnose a really critical lung infection, and how it could totally change the game for doctors.
And really, this is the big question that kicked this whole thing off. It's such a powerful idea, right? Building an AI that can work at the level of a human expert. But let's be super clear. This was never about replacing doctors. It's about creating an incredible new tool to have in their corner.
And when it comes to pneumonia, the stakes, well, they couldn't be higher. Every single second counts. If an x-ray gets delayed or misread, it can lead to serious problems. And that is the real-world challenge this AI was built to tackle. So, let's get into it. Before we dig into the nuts and bolts of how you actually build an AI like this, it's worth asking a simple question. Why even use artificial intelligence for this in the first place?
Well, there are some pretty clear wins here. An AI can potentially boost the accuracy of a diagnosis, and it can definitely speed things up in the clinic. Plus, a model provides a consistent analysis that never gets tired or has a bad day. The big takeaway, though, is that this is designed to be a reliable assistant for radiologists, helping them make better, faster calls. But, an AI like this isn't just born smart. It has to go to school, so to speak. It needs to be trained. And that whole process, it all starts with the data. Let's take a look at how they get it ready. This is the essential prep work, and it's super important. First up, thousands of X-ray images get loaded in. They all get resized and normalized so the model is looking at everything in a consistent way. Then comes this really clever step called data augmentation. We'll get to that in just a second. And finally, the classes get balanced, which basically just keeps the model from getting biased if it sees, say, way more healthy X-rays than ones with pneumonia. So, what is this data augmentation thing? Well, it's actually a pretty simple but brilliant idea. You take the images you already have and you create slightly tweaked copies of them. You might rotate one a little, zoom in on another, maybe flip one horizontally. But why would you do that? It's all about one thing, really. You want the AI to learn what pneumonia looks like in general, not just to memorize the exact photos you showed it during training. This whole process makes the model way more robust, so it's much better at diagnosing brand new X-rays that it's never seen before. It is the absolute key to making it work in the real world. So with all the data prepped and ready to go, it was time to actually build the brain of the operation. And the approach here was really cool. They basically set up a head-to-head battle between two totally different AI models to see which one came out on top. In one corner, you've got a custom-built model, a convolutional neural network, or CNN, that they made from scratch. It's a great way to learn, but with a limited amount of data, it's probably going to struggle a bit. And in the other corner, we have MobileNet v2. Now, this one came into the fight with a huge advantage because it had already been trained on millions of images from all over the internet. This quote just nails the whole idea behind why MobileNet v2 was so much better. It's a concept called transfer learning. You're not starting from square one. You're taking all this existing knowledge about what shapes and textures look like, and you're just fine-tuning it for one specific job, spotting pneumonia. This approach is an absolute game changer, not just here, but for pretty much the entire field of AI. Okay, so we've got our data, we've picked our champion model, but how did it actually do? Time to look at the final results, the numbers. And the headline number is a solid 87% overall accuracy. So 87 times out of 100, the model got it right. It correctly identified whether an X-ray showed pneumonia or not. That's a great starting point for sure. But in medicine, you really have to dig deeper than that top-line number.
So, when we break it down, this is where things get really interesting. Take a look at that recall score for pneumonia. It's sitting right around 90%. Now, recall is just a way of measuring how good the model is at catching all the positive cases it's supposed to. And for something like this, that number is everything. The F1 score, by the way, is just a handy way to get a combined grade for performance.
So why are we so focused on that 90% recall? Well, here's the deal. A high recall means the model is fantastic at not missing actual cases of pneumonia. It cuts way down on what we call false negatives. The worst case scenario where you tell a sick person they're fine. In a hospital, being able to catch 9 out of every 10 real cases, that's a powerful safety net. Okay, so having a super accurate model is one thing, right? But it's pretty useless if it's just stuck on a lab computer.
The final piece of the puzzle was taking this powerful AI and making it accessible and easy for anyone to actually use. And to do that, they converted the model into something called TensorFlow Lite. The best way to think about it is like taking a huge, complex encyclopedia and creating a super efficient pocket guide. It's the same core knowledge, just packed into a tiny format that can run right on your phone or a simple website.
And here's what that looks like in the real world. They built this simple little web app. All you do is upload an X-ray image and boom, in seconds, the AI gives you its analysis. It's all about turning that complex algorithm into a tool that's actually, usable.
And check this out. Here it is in action. Someone uploads an X-ray that does have pneumonia. The model crunches the numbers and comes back with a verdict. 86% confident that it's pneumonia. It's fast, it's clear, and it shows you just how powerful this could really be.
At the end of the day, what this whole project really proves is that we can take public data and accessible tools and build something that could have a massive real-world impact. It's a fantastic reminder that AI isn't just some abstract sci-fi concept. It's becoming a powerful ally that, if we use it the right way, could genuinely help save lives.